Hello, I'm Eric Snodgrass, and thank you for watching today's long-range technical forecast video brought to you by Nutrien Ag Solutions. This analysis is being provided for perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that all long-range weather forecasting is speculative by nature. We look back over the last couple of weeks here, and a lot of folks are going to remember the end of November and the beginning of December as being quite dry, specifically in parts of the Midwest and really the northern plains and then much of the western part of the United States. There have been a few corridors of pretty heavy precipitation and quite a bit of cold weather that has been over parts of the southeast. In fact, we've now seen frost temperatures get pretty far south into Florida after making their way all the way to the Gulf Coast. We've had some pretty decent cold air intrusions. But coming back to precipitation, you can kind of see this corridor in through here been quite wet when we look back over the last couple of weeks, as has this region right in through here. We're going to talk more about that second region there in the central part of the U.S. in a few moments. First, take a look at these temperatures. So with that ridge that built up into Canada, underneath it or south of it, we have got temperatures today where we're going to be seeing mid to possibly upper 60s in parts of the central plains. In fact, take a look at the numbers. It could possibly be warmer today in Nebraska and parts of South Dakota than it will be in Miami. So the cold air is exiting east and the warm air is spreading across the midsection of the country. I just want to give you a quick update on this. So as we go into the day on Thursday, you see the warmer air starting to spread east here. Then we go into Friday. It finally gets over to parts of the Ohio Valley and then the east. But then you notice on the back side of this, there's some pretty cold air that's coming out of the Four Corner states into the southern plains. And that's because this weekend we're watching a low pressure system basically run right in through this area before taking on off toward the north and east. So the temperature is really cooling off behind that. Now, to show you the flow of the atmosphere by the time we get there, we're going to be really replacing that large ridge in the central U.S. and Canada with a pretty broad trough. So the jet stream, once we get toward the 11th of this week, we'll be doing that with a bit of a subtropical branch down here. And the combination of this, trough plus the little jet streak to the south and the one that's exiting here is going to give us really good upper level support for the development of a low that's going to come out of Texas and head toward Missouri, Illinois, and then eventually to the northeast. But the models have been a bit, not in agreement. And I want to talk to you about why I am favoring the European solution on this, but I'm going to give a pretty big caveat on that. I show you these every once in a while. These are produced by Dr. Ryan Maui, and it looks at the skills score. This is the model's ability to properly forecast the 500 millibar pattern. So we're just looking at its ability to pick up on basically the jet stream pattern. And you see the blue line on top there represented the ECMWF, and the bottom one in red is the GFS. So just look lately. The European's been steadier, and the GFS has been improving after a really poor bit of performance back in mid-November. So still, I need you to know that as we then go into this multi-model analysis. So I'm going to show you over here the European on the right and the GFS on the left. These are the operational 0Z runs from today. As we play this forward, they are in really good agreement with what's coming out of Texas. So by the time we get into Friday morning, we'll see a leading edge of precipitation that will move from this part of Texas through the Red River Valley up into parts of Oklahoma and Kansas. And both models have that there. We then play this forward, though. Look at the difference maybe in the timing between the GFS and the European. The European a bit slower. You can see the center of low back here with the pressure troughs extending out where the warm front will be here into Indiana and Ohio. Where the GFS has just got this already in Arkansas. So that's a difference that we have to pay attention to. But they both move through. And they develop over Illinois. Just again, while the center's over St. Louis in the European, it's over Champaign, Illinois, where I live here in the GFS. So a little bit different in the timing. And because of the slowness here, a lot more snow, I think, on the back side here is going to show up in the European because of that. And even some leftover snow stretching all the way back through Kansas and Oklahoma. I'll show you the snow maps in a few moments. But as we move forward, that system then wraps itself up into the northeast, as you see here. And this is where the models really just... they completely split away from one another on Sunday. And it's happening right here. You can see that in the European, we're not only bringing in more snow to the parts of the southern and central plains, and also right here along the Gulf Coast, more rainfall. Well, that's happening because there is a new trough developing here in the Euro that's way more open in the GFS and moving quicker in the GFS. So I know I'm just explaining to you model differences here, but what we have to do at this point, the meteorology of this, is to watch the trends and then try to pull in the reasoning behind it, which is why we're doing this today in the near term, and I can do it again tomorrow morning for you. So look at the difference. With the European, ejecting this trough right here out of the Gulf and slowly moving it to the southeast, versus the GFS tossing it clear over here to the Carolinas much quicker. High pressure builds in the GFS, and we have a low in the Euro. Look at this. And the European model in the last 2 runs has produced this low here, such that by Monday afternoon it's sitting somewhere over the Carolinas and snowing in the Appalachian Mountains, all the way back into parts of the southeast. I mean, this is bringing snow to northern Alabama. And then it runs on off. Look at what's going on with the GFS. It's got a big high pressure cell right here. No agreement at all in this, because how quickly the GFS gets rid of that trough. Now, I showed you the skill scores for a reason. The European's been a better performer on picking up the upper level flow pattern. So you have to look at that and go, well, I should trust this, plus there's 2 different model runs giving it to us. But remember, it is always, it doesn't matter what time of year it is, hard to forecast snow down here. Just it's brutally difficult to do that. So we're going to watch the model trends, and I'm going to report to you again tomorrow what's going on with those 2 systems. All right, so we'll get back to that. I want to give it to you like this though first in terms of snowfall with the first system. The models do agree. Look at this is the GFS and this is the European, that corridor in through there, stretching all the way from Colorado through the Kansas-Nebraska border, through parts of Iowa, Illinois, Michigan. That's going to be the corridor where we're going to expect to see some snowfall. The amounts range, 2 to 4 inches across Kansas, Nebraska into Iowa, but then you can see right in through here the European really picking up. Now this is the operational run, really picking up on quite a bit of snowfall in northern Illinois into southern Michigan. Now, what's going to be controlling this will be where the high pressure cell sits to the north and how strong will that high pressure cell be as to how far to the north or south this line gets. Because when you look at the ensemble, this is just the European, this is the probability of getting 3 inches. All right, so we look at that and we see that that corridor, I'll just draw a line right through the middle of it, is a bit farther to the north. So this would be the variation in the strength of the high to the north. And to finish this story here in the near term, this is the difference. Can you see how the GFS, by the time we get to Monday morning, has got that trough clear over here, ridging on the back side of it, and we know what we get there. That's where we have our high pressure systems developing, and that's what we get. But the European closes this low off, slows its movement over toward the Carolinas, and that's where we produce that next system. And the last 2 runs of the European has given that. And so I can't wait till midday today to see the 12Z run from the Euro to see does it continue to do this, because these little cutoff lows have kind of been a bit of a speciality for the European. It's been trying to produce them, and on occasion they've materialized, and at other times they haven't. And be honest with you, this all started on Labor Day. Do you remember that big one that cut through parts of the high plains? I mean, dropping temperatures 40 degrees below normal back on Labor Day. That's when I think the Europeans gotten pretty high here on producing these little cutoff lows. Okay, I wanted to get that near-term stuff out of the way and just remind you that this is the feature we're going to watch early next week, and that the models are not fully in support of its development here, but it's trying. The ensemble's trying to put something down into this area. You can see pretty big spread there on the position of those lows, but it's not high pressure in that place, which is what the GFS is saying. Now let's get longer term. Both models do somewhat agree on this day 10 pattern, anchoring the tropospheric polar vortex, which is this trough somewhere here between Alaska and the Canadian archipelago. The only difference is the GFS has got a little bit farther back, and it's even got a bit of an extension of that trough farther to the east, right over in this area. And I'll show you the difference in a few moments, whereas the European kind of brings in flow a bit more like this. Okay, now what are the implications of those differences? Well, the GFS, just look at it again. See the trough that's right down here? That's part of the reason why it keeps this corridor wet. But the European, I think, has just got the pattern better here. And I think what we're going to end up seeing is most of our wet weather is going to be tucked away in the northwest part of the United States. Unfortunately, as I have said so many times, I just don't see, while this La Nina continues to peak, I don't see a reason for the subtropical jet stream to emerge. But I see a storm track that's going to continue to funnel through here. So I know you're looking at this going, but it says dry. I'm saying through the middle of this month and then getting even up to the week before Christmas, we're going to have systems rolling through here. Nothing's going to shut this back off like we had seen lately in parts of the Midwest with it being drier. I think that's how the pattern's going to go. The temperatures are responding accordingly. See the colder air tucked away here, and this cooler air that you see down here along the south, while it is kind of in both models, at least near normal, this again is just a reflection of that slow-moving trough that's coming out here in the day 5 through 10 time period. That's in the European. The GFS says, shove it off the coast much sooner. Okay, from there, let's look out beyond that because they do somewhat agree on the day 10 through 15 pattern, which gets you out to Christmas Eve here. Broad scale across the United States, slight warm anomalies with all the cold air really anchored and tucked away inside of the tropospheric polar vortex. And I'll explain the difference in a moment over parts of Alaska and Canada. That's where the coldest air seems to be sitting here. So I'm going to look at this and I want to try to explain the meteorology in the models, though. That's what's tricky here, and I'm going to try to add to this my own opinion. So first things first, what about the tropics? When looking at something called the Southern Oscillation Index, which is basically giving us a measure of really what's going on with El Nino and La Nina, I put together a correlation map here for December. And what we notice is it tends to give us this, ridging off the coast here, troughing in this area, and troughing along the east. So we can see those three places, and then look at the ridging that happens here. All right, when I examine that pattern, I then think about, well, what's going on in the tropics? Okay, the Southern Oscillation Index is way up here at plus 10 right now. That would be definitely La Nina in behavior. Remember, we just need to be above about 7 to be really considered moderate strength La Nina. And we can see that the trade winds are given this big push right here. That's what those blues represent. Strong easterly trade winds cutting across over the next 15 days. Now, I saw this, and then I saw the Southern Oscillation Index peaking, and I started to think about what's happening behind it over here. And I'm going to show you the latest sea surface temperature anomaly map. Because out here in Nino region 3.4, that's inside that little rectangle I drew there, these ocean temperatures are down there around minus 1.25 degrees Celsius. But over here, and over here next to South America, while you may notice the colder water extending down, regions that I just put ovals around there are warming right now. And there's climatological evidence and some near-term meteorological evidence that would suggest that maybe we are witnessing the peak push of this La Nina, going up to Christmas, which, to be honest with you, is why we even call it El Nino and La Nina, because they typically reach a peak at Christmas time. In fact, the El Nino referenced here is baby Jesus. That's what the Peruvian fishermen named it after. So they found that this peak of the warming or the cooling of the ocean waters tend to happen right around the end of the year when we celebrate Christmas. Okay, so this is making a lot of sense that it might be giving us its last big push, and it might stabilize and weaken from here on forward, which calls this into question. Now, first, some correlation, then some questions. The MJO currently is over here sitting in phase 4, and it is forecast to just squiggle and meander somewhere over here in phase 4, 5, and get over into phase 6 over the next month, all right? Now, something to remember, phase 5 of the MJO correlates historically to that temperature pattern. You can almost see where the cold air is up here. It's off my map, but broad scale above average temperatures would be the name of the game. And phase 6 looks something like this. So again, the lower 48 relatively mild for December. So it's still cold, but it's mild with all the cold air here. And if you remember back, that's almost exactly what the models were forecasting. So I start to look at this and say, are we really seeing that it's the tropics dominating the pattern going through the rest of the month? And if the MJO stays over here in 5 and 6 and does not wall all the way over here, all the way over here into phase 7, 8, 1, and 2, well, then there's no tropical reason for these maps on the right to be wrong. That's what I'm trying to explain. From there, let's at least look at the long range. Can you now see that the models are responding to that? Week 4 temperature anomalies. Week 3, they're keeping the cool air in the Canadian prairie toward Alaska. They're also allowing for an active storm track to be doing this, which is why I told you I think this area is going to continue to see a lot of action into week 3 and even into week 4 as well. But notice, I'll just draw a line on it. You're south of that line in the west without a strong subtropical jet stream component. We're just in trouble. This is just not the right configuration to bring in the moisture to California, which is desperate for it. So let me add to that another layer. Let's go now to the Arctic. We looked at the tropics, let's go to the Arctic. We are seeing the Arctic oscillation go negative, and you can see the forecast of it up here from the European ensemble. Now, what does that typically mean? If the Arctic oscillation goes negative, which again, the Arctic oscillation is a pressure pattern change over the Arctic, where we tend to see when it's negative ridging at the surface pressure level over the Arctic versus the positive phase when we tend to get lower pressure there. So we would have expected with this a temperature pattern like you see here, but we're almost getting the opposite of that. And therefore, when we look at that and compare it to what the East Pacific Oscillation is doing and the North Atlantic is doing, which neither of those two are really breaking strongly away from what I would call neutral, I then say, well, is anything happening in the stratosphere? So let's go take a look. Now, over here on the left, this is the stratospheric polar vortex. And you can see, and you're going to watch this with me, that we get quite a bit of warming here. And with time, we get a lobe of the polar vortex, this is the stratospheric one, breaking off and going here, while there seems to be some pretty significant warming in the stratosphere here over this part of like the Chukchi Sea over to Siberia. Now, we have to ask though, is it strengthening or weakening the winds? Because ultimately it's measuring the winds that we care about. And that's coming back to the figure over here on the right. You see, we do get this weakening. It's right here now, and it's forecast to go down to that point. But still, average is right in through here. So it's not as though the stratospheric polar vortex is doing this, which means that even though, just look at this with me, okay? Even though the center seems to be in this area, look at what's happening down at where the tropospheric polar vortex is. It's not here. It's instead centered here. And that's why I don't think right now that we can use the Arctic oscillation as a measurement for where that cold air is going to come from. This does mean the jet stream is going to scream in this direction, though, which says the middle and end of this month of December, I think, is going to be exciting in this part of the world and up to the East Coast and in the Northwest and along the U.S.-Canada border. Now remember, when meteorologists get excited, that typically means that the weather becomes a bit more adverse, and we're going to see some changes there. I am mostly interested in this too. Do we really get ridging happening here that bulges up here into the Arctic? And does that extend itself to displace what's happening here? I'll put an X in it. That would be the big questions I'd have by the time we get to the end of this month. Now, quickly, back to the tropics. We know that phases 4, 5, and 6, let's just highlight them over here. Whoops, sorry. Try that again. 4, 5, and 6 tend to be drier for Brazil. See that? And the MJO doesn't want to leave 4, 5, and 6. If it would come over to 7, 8, 1, and 2, we would expect to see, look at phase 2 or phase 8 or 1. We would expect to see a lot more precipitation there. So I look at this and I get a little bit confused by these maps. This animation is from the European weeklies that just came out. Yep, we're getting great rains right in through here this week. And I'm going to put an X in Mato Grosso here. But let's take that off there and just put the X. As we go forward, remember, this is a place that has struggled a lot with rainfall. As we move forward in this forecast, let's pause it right here. Going out into week 2, that whole region goes over dry, which is what I'd expect with the MJO going to phase 5 and possibly to 6, wetter farther to the south. But then as we go forward at the end of this month, look at this. Let's just get you to the week ending on Christmas. I start to see wetter weather coming back in here, wetter than normal. And the model wants to keep that wetter weather around for a while in this region. And I start to think about that and see some inconsistencies with the behavior of the MJO. Now, I know that the MJO is not the only thing that controls South American weather, but it has been a dominant factor because of the La Nina. The two kind of operate in tandem at times. So this is an interesting thing because the model would suggest that the end of December through the beginning of January, we've got excellent rains in some of Brazil's best growing areas. So if that does return, does it undo the damage already done? No, it doesn't. I don't think it can. There's not enough time here. But now we start to ask ourselves another question, and we get to this map. This is the precipitation forecast for February. And what I want you to watch in February is this area right in through here, specifically Mato Grosso. The models have been a bit off in forecasting the precipitation patterns for those areas. And what I want to know is this region going to be wet? If it's wet, remember we had planting delays. If it's wet in February, we'll have harvesting delays and then planting delays again on the safrinha corn crop. What I'm coming back to here is I think that February is going to be our next critical time phase for the South American soybean crop to watch carefully. So we'll keep analyzing that and keep watching it. Certainly going over dry in week 2, though. Please remember that. And there's some uncertainty in the longer range. Here's where we finish. I showed you on Monday the long-range data from the European. I told you I'd do today some kind of analysis on how well it's been doing. Back on August 1st, this was the forecast for September, October, November. We were looking for wetter conditions in the northwest, wetter conditions along the coast, drier than normal in the central part of the country. We can actually see that the models did okay with this pattern. That's all we use it for, is a pattern. We don't use it for values, we use it for a pattern. Certainly there were places that were, missed, like right here in this part of the Corn Belt and, southern or lower Mississippi River Valley. There was a hurricane that went through there in September, so it didn't pick up on that. But I can't say that this did a terrible job of the pattern for our fall. I think it even did a better job with the temperatures. Look at this. This is the global average temperature anomaly zoomed in here on North America. Over the time period of September, October, November, warm here, warm there, and October only was brutally cold in this area. The model said for September, October, November, warmth, I'll put an N for near average, but you'd say, well, didn't it miss here? Well, for parts of October, yes, but in September and November, it was very warm in those areas. So I've got to kind of tip my cap here and say, European model, I think it's actually doing a halfway decent job with this. So now we put this back into context. Do you see how we see that cold air anchoring over Alaska right now? The models want to let that happen throughout the remainder of the winter season. And there's broad scale, mild winter temperatures. Now, mild does not mean no snow. It just means that we will favor more mild days than we will the cold days, according to the European model. Now, that is going to be met with some caveats, just so you know. And I think it's a bit too mild at this point, given that the La Nina will be around. But that's just my opinion of me assessing what I think the European model is biased toward during winter. Precipitation, same line. Do you see it? Without that subtropical jet stream, I'm concerned. And then, while you're going, wait, I see dry in here. Remember, this includes December. The first map I showed you, remember how dry it was in part of that area? Look at how dry it was here. This is baked into this forecast. But look at as we go out here to January, February, March. The European says, keep that Ohio River Valley storm track going. Keep the Northwest wet, the Canadian prairies with a bit more snow. Same thing for the Northern Plains. But without that strong subtropical jet stream, it just wants to keep the South dry. And that helps kind of put into context that long-range data we got from the European last weekend. Okay, thanks for your attention. Have a good rest of your week. I'll talk to you again in the morning. Thanks.